Hello my dear students, I hope you all are fine and you have gone through the part 2 section of the atomic structure which has been uploaded in the middle school YouTube channel. So today we are going to deal with part 3 of the same chapter, that is chapter number 4, atomic structure, and the subtopics that we are going to deal today is mentioned in your page number 65 to 69 of your textbook. And the subtopics that we are going to deal today are number 1, arrangement of electrons in atoms, and number 2, electronic configuration. And under arrangement of electrons in atoms, we are going to study two models. Number 1, Rutherfords model, and number 2, Bohrs model. Coming to arrangement of electrons in atoms with respect to Rutherfords model. Rutherford said an atom has a small positive nucleus in the center and which contains two subparticles, that is protons and neutrons, which you already know of. Then number 2, it also says that negatively charged subparticles, that is electrons, will revolve around the nucleus in the same way as planets orbit around the sun. However, please keep this in mind that Rutherford's atomic model could not explain the stability of an atom. Why is it so? Because if electrons moved around the nucleus as described by Rutherford, then they would very quickly lose their energy and fall into the nucleus. And if this happened, the atom would then collapse. Coming to Bohr's model, Bohr slightly modified the model given by Rutherford. So he said that electrons revolved around the nucleus in fixed circular paths called cells or energy levels. In contradict to this, Rutherford had said that electrons also revolve around the nucleus, but he said that they revolve around the nucleus in a haphazard manner. But Bohr said that they revolve, that is the electrons revolve around the nucleus in fixed circular paths called cells or energy levels. Please have a look at the figure 4.11. It represents nitrogen atom according to Bohr's atomic model. In the center of the atom, what is located? Nucleus. And which subparticles would be present inside the nucleus? Protons and neutrons. And with respect to these diagrams, you can see that in the nucleus there are red dots and blue dots. In the red dots, they have designated plus sign, and blue dot does not have any charge. So these red dots with positive charge is representing which subparticle? It has to be protons. And what about the blue dots without any charge? It has to be the neutrons, isn't it? And outside the nucleus, you can see that there are how many concentric rings? 2 concentric rings. What are these concentric rings then? These are cells or energy levels as said by Bohr. And what is present in these cells or energy levels? You can see those pink dots with negative charge designated. So what are these? These has to be electrons, because electrons are negatively charged subparticles. Okay. Second point, which he also said that the cells will have fixed size and energy. With respect to this, these 2 points you have to keep it in your mind. It's very, very important. That is number 1, as we move from the nucleus to the farthest cell, that is from n equals to 1 and n equals to 2 and so on, then the energy of the cell will also increase. In simple words, I can explain you this way. Which is the cell that is closest to the nucleus? It has to be K cell, and after K cell it would be L, and after L M, and after that N. So what do you think? Which is the cell that is closest to the nucleus? K. And which is farthest? N, isn't it? So according to this rule, it states that the cell which is closest to the nucleus will have the least energy, and the cell which is farthest with respect to the nucleus will have the maximum energy. So as you move away from one cell to the another cell, the energy will also increase. So if I give you these 4 cells with respect to an atom, that is K, L, M and N, which cell will have the least energy? Yes, K, isn't it? And which will have the maximum energy? N, because N is the farthest cell. Am I clear? Second point which you also need to remember is that an electron normally occupies an energy level called its ground state. Under normal conditions, the electrons which are present in the cells is designated as ground state. However, if you supply energy to the atom, then the electrons will start absorbing the energy, and these electrons will jump from lower energy level to the higher energy level. Is that clear? So when the atom gains energy, the electrons gets excited and then they jump from one energy level to the next higher energy level. And under that state, the atom is said to be in excited state. Have a look at figure 4.12. It is the representation of ground and excited state of an atom. You can see that it has 2 cells, isn't it? K and L cell. And in the K cell, we can see it has 1 electron, isn't it? And that electron is gaining energy, isn't it? Before that, the electron that is present in the K cell is designated as ground state energy level. Once this electron absorbs the energy, it gets excited and it then jumps to the next energy level, that is L, isn't it? From K it will jump to L, and then this state of an atom is said to be excited state, and the energy level would be excited state energy level. I hope I am clear. Alright, now coming to electronic configuration. So what is electronic configuration? It is the distribution of electrons revolving in different cells, which is also known as energy levels around the nucleus of an atom of an element, isn't it? Now these cells are filled with electrons based on the formula, that is 2n square, where n is a natural number, that is 1, 2, 3, 4, isn't it? And it also designates the number of the energy cell. If it is 1, that is the cell which is nearest to the nucleus, and 2 just beyond the first cell, and as it increases, the number will also increase. Now, how are the cells designated with reference to alphabets? It is designated as K, L, M and N. So please tell me, what will be the value of N for K cell? It will be 1. What will be for L? It will be 2. What will be for M? It will be 3. And what will be for N? It will be 4. Is that clear? Please keep this formula in your mind, that is 2n square. With this formula, we can calculate that how many maximum electrons can be accommodated in a particular cell of an atom. Alright. Okay, so this slide gives you an idea about the maximum number of electrons which each cell can hold. So which formula we are using it? 2n square. So on the left hand side, you can see that there are cells, that is K, L, M and N. And what is the value of N for K? 1. What is the value for N for L cell? It is 2. Likewise for M it is 3, and for N it is 4. Apply this formula for all these cells. Then you will get the maximum number of electrons which each cell can hold. Okay, let's find for K cell. So 2 is constant, isn't it? And the value of N for K is 1. So 2 into 1 square is 2 into 1 equals to 2. That means K cell can maximum hold only 2 electrons. Same way, apply the formula for L cell, isn't it? 2 into, what is the value of n for L cell? 2. So 2 into 2 square it is, 2 into 4 equals to 8, isn't it? So how many electrons maximum can L cell hold? 8. Likewise, for M and N, the answer we get is 18 and 32. So N cell can maximum accommodate 32 electrons. Now, this slide gives you an idea about the element, the atomic number, electronic configuration, and the atomic structure. So you should be able to draw the atomic structure, write the electronic configuration from elements with atomic number 1 till element with atomic number 20. Is that clear? In class 8, you will not be provided with the atomic number, so it is advised that please remember the atomic number of the elements starting from 1 till 20. Okay, let's take the example of the first element of the periodic table. It has to be hydrogen. Its symbol is H and atomic number is 1. So the electronic configuration can be written as 1, isn't it? So that 1 electron is present in which cell? It has to be K cell. And just have a look at the atomic structure of hydrogen. You can see that in the center it is nucleus, and what does that nucleus contain? That one p is denoting it is containing one proton, and it has only one cell. Which cell is that? K. And what do you see in that K cell? Only one electron, that is designated as red dot. Likewise, for helium, the symbol is He, atomic number is 2, electronic configuration can be written as 2. And if you see the atomic structure, you can see that it has 2 protons, 2 neutrons in the nucleus. And how many cells it has? Only one cell, that is K cell. And the K cell will hold how many electrons? 2 electrons in helium. Likewise, for lithium, the symbol is Li, atomic number is 3, electronic configuration is 2, 1. So as you know that K cell can hold maximum of 2 electrons. So where will that one extra electron go now? It will go to the next cell, that is L. So if you see at the extreme right with respect to lithium, the atomic structure, you can see that it has how many cells? It has 3 cells, isn't it? Sorry, 2 cells. It has 2 cells, that is K and L. K cell has 2 electrons, and how many electrons are present in the L cell? Only 1 electron. Likewise, in this slide, I have written the elements from beryllium to sulfur with its symbol, with its corresponding atomic number, and I have also written the electronic configuration. However, you can see that I have left some gaps, like I have not written the electronic configuration of carbon, oxygen, isn't it? Magnesium, aluminium, phosphorus, and sulfur. Why is it so? Yes, you have to do it on your own once you have understood this concept. Now, coming to sodium, have a look at the sodium. Symbol is Na. What is its atomic number? 11. And then the electronic configuration is written as 281. If we add all this, what do we get? 11, which means if you add the electrons that is written in electronic configuration, you get the atomic number as well. Is that clear? So 2 electrons is present in the K cell of the sodium, 8 is present in the L, and then 1 electron is present in the K, L, and M, isn't it? K cell has 2, L has 8, M has 1. That means sodium has how many cells? It has 3 cells, isn't it? Likewise, you have to try for the remaining ones. Coming to the last slide, it has elements like chlorine, argon, potassium, and calcium. Please try to write the electronic configuration for chlorine, argon, and you can see that I have written the electronic configuration for potassium. It is 2881. If you add all this, you get the value as 19. So with respect to potassium, K cell will hold maximum how many? 2 electrons. L will hold maximum 8 electrons, then M will hold maximum 8 electron, and then the remaining 1 electron will move to the N cell. So potassium has how many cells? It has 4 cells. Likewise, try to write the electronic configuration for calcium also. Don't put it this way, 2, 8, 12. It cannot be written that way. Please use the concept which I have used for writing the electron configuration for potassium. Once you are done with writing the electronic configuration of the left outs of the elements, you should also be able to draw the atomic structures of all the elements with atomic number from 1 to 20. This you can do only if you remember the atomic number of the element, you know how to write the electronic configuration, then only you will be able to draw the correct atomic structure of that particular element. I hope this video session is clear to you. If you have any doubts with respect to this part 3 session, please feel free to WhatsApp me in my personal chat, not in the group. Is that clear? Thank you. Stay home, stay safe. My regards to all of you.